So, in today's experiment of determination of pH of different food samples, the material and equipment required will be, you can see there is a pH meter along with buffer solution, 2 buffer solutions 4.01 and of pH 7. Along with that, we will need some food samples for which we are going to determine the pH. There is ammonia solution, baking soda solution, lemon juice solution and milk. Along with that, we have tap water and distilled water. Since we are going to determine the pH of food samples with the help of both pH meter and pH paper. Another sample which we are going to use is that of aspirin. So, it is an aspirin tablet. We will be preparing a solution of aspirin by using pestle and mortar, 1 tablet crushed and ground and made into 20 ml of water, distilled water. In order to prepare for the experiment, first the pH meter needs to be calibrated. So, the pH meter is first calibrated with a buffer solution of 4.01. As you can see, it is already placed in a buffer solution of 4.01 and on the display you can see a reading of 4.01. Now, we are going to calibrate it with a buffer solution of pH 7. For that, first of all, we are going to remove it from this buffer solution and next we are going to wash the probe, the electrode with distilled water. It is very important step while you are using a pH meter because it is dipped in a solution, and so next time when you are measuring another solution, it needs to be washed thoroughly. And then after washing, it is wiped gently with a tissue paper. Make sure the membrane is also dry and it is cleaned gently. Next, we are going to place this probe. As you can see, this is a buffer solution of pH 7. Place this probe in a buffer solution of pH 7 and press cap. Okay. So, as you can see, the readings are changing and it should stop at pH 7. As you can see now, the display is showing pH 7. So, that means the pH meter is calibrated and ready to be used. Now, we start the measurement of our first sample, that is milk. So, we have already washed the electrode with water and wiped it with a tissue paper. Now, we are going to dip this probe in the milk sample which is taken in the beaker. The sample should be enough to dip the electrode properly and then we are going to press read. As you can see, the reading is being measured. Once the reading gets fixed on the display, that is the pH of the given milk sample. So, you can see the reading over here 6.71 and that is the pH of the milk sample. The pH can also be measured with the help of pH paper as we showed you before. So, I will dip this pH paper in the milk sample, and then we are going to match the change of color with the guide given on the top of the pH paper. So, if I try to match it, you can see it is coming somewhere between 6 and 7, towards 7. Almost no color change is observed. So, as we can see, pH paper will give you approximate reading, maybe a range of the pH, but with the help of pH meter you get the exact reading. Similarly, we are going to perform with all the samples. Our next sample is lemon juice. So, a small amount of lemon juice is taken in this beaker and the electrode is dipped in the lemon juice, and we are going to press read. You can see there is a change in the pH from the earlier sample, and it is showing a highly acidic pH of 2.54 right now. It is still measuring. Let us see where it stops. Okay, so the pH of the lemon juice is 2.51, as we can see. The measurement of pH can also be done with the help of pH paper. So, we will take a bit of pH paper and going to dip in the solution. You can see there is a color change. Now, let us match the color with the help of pH paper, and based on the guide which is given over here, the color approximately matches to pH 3. So, you can see we can get a range over here between 2 and 3, if I can say, and you can see that it falls in the range in the pH that is shown by the pH meter. So, with the help of pH paper we can get the approximate reading, whereas with the help of pH meter we can get the exact reading of the solution. So, as you can see, lemon juice is highly acidic and it is reflected by the pH which is showing over here. Most of the food items are acidic in nature, but let us now test the pH of a baking soda solution. A baking soda solution or baking soda is often used in cooking. So, let us now see whether we will get an acidic or basic pH for the baking soda solution. Again, this is a cleaned electrode which is dipped in the baking soda solutions, and now we are going to press read. You can see there is a rise in pH, and this pH which it is still measuring, it is falling in the range of basic. So, basically so we have the reading now 9.29, and that is the pH of a baking soda solution. So, it is alkaline in nature. We can measure the same with the help of pH paper as we did for the other solutions. So, again we are having this pH paper which I have held with the help of forceps, okay, and this is our guide. So, again I am going to dip this pH paper in the baking soda solution. Quickly you can see there is a color change, and this time the color falls in the basic range. Let us try to match it. So, as you can see, roughly the color is between 9 and 10, which is in accordance with the value which we are getting over here. Yeah. So, it is not exactly like 9, but also not exactly like 10, but easily we can identify that this solution is a basic solution. Similarly, we can perform the pH measurement for different type of solutions which were shown to you earlier, like the ammonia solution, tap water and distilled water. the same procedure will be followed, and as was told to you in the starting, an aspirin solution can also be measured with the help of pH meter and pH paper. So, we have a suspension of this aspirin solution. A tablet of aspirin was first crushed with the help of pestle and mortar, and then solution was made. So, we can measure the pH of this aspirin solution again with the help of pH meter and also with the help of pH paper.